All right, so we got Mario driving to Edmonton to Grand Prairie and back. It's 300 kilometers each way. He drives faster on his way home than he did on the way there. And his total driving time was 10 hours. So what we're going to put off to the side here is we're going to put some notes. We're going to call these questions distance, speed, time questions. And what we're going to do is we're going to develop a strategy to help us solve these, because these are complicated questions. You read the question and sometimes you feel like, I don't know where I'd even start, because it's a lot of information and a lot of data. So the first thing that we're going to do for these distance, speed, and time questions is we're going to set up a chart. And our chart will always have distance, speed, and time in some form that way. Just like the chart that's set up for us right here.
Can we use that chart?
Yeah, and we're going to use this chart, but as far as we're just writing our instructions down right now. So our strategy for any distance, speed, time question, we're going to set up a chart. This one's already been set up for us. Once we've set up our chart, because some of the questions in your homework won't have a chart made for you, so you'll have to make it on your own. Once you've set up the chart, you're going to enter the data you know. So this chart here has been set up for us. What data do we know? We know the distance. We know the distance is 360 for both ways. That's the only data that we know exactly, because the total time, which would be both of these together, is 10, but we can't put in the numbers for each one. And we don't know the average speed he traveled, so we can't put in things for that. Yes, we can put x and x plus 30, and that's going to be the third thing I'm going to write down. We're going to choose a variable, only one variable, and then complete the chart. And we're going to have to use, in order to complete the chart, we're going to have to use our formulas. Remember yesterday we talked about speed. If you're talking about speed, you're talking kilometers per hour. So our formula for speed is distance over time. Rearranging this formula, you get time is distance over speed, or distance is speed times time. All three of those are the same formula, just with the variables rearranged. So the suggestion here is saying, well, let's say on the way there our speed is x, then we should be able to fill everything else out using only that variable. So if the speed was x on the way there, how fast are you going on the way back? X plus 30. In order to fill out our times, we go to these formulas. What's time equal to? Time is equal to distance divided by speed. So the time in this first one will be 360 divided by x, whatever that speed is. And our time in our second one will be 360 divided by x plus 30. Finally, once you've filled out the chart, you're going to set up an equation using the information given in the question. So we've set up our chart. Now we're going to go back to our original question and say, how is there something from within this chart so that I can write an equation? What is the only information that we haven't used yet? we haven't used this. His total driving time was 10 hours. So if you know that his total driving time is 10 hours, how can we make an equation using the data in this chart? Can you see that this 360 divided by x plus this 360 divided by x plus 3, those are both times, right? If you added both of those together, what should they equal? They should equal 10. So we get an equation that says 360 divided by x plus 360 divided by x plus 30 should equal 10. And we've made an equation. And it's a rational equation. So now we can go to our strategies of either multiply to get rid of things or get a common denominator. Can you see that this one's missing an x plus 30? This one's missing an x. And this one, which is over 1, is missing an x and an x plus 30. And once we have that common denominator, we're going to get 360x plus, some big numbers here. Is this going to be 10,800?
No, 1,080.
Yeah, is good? Okay. Plus 360x equals 10x squared plus 300x. Yes, the numbers are big enough to warrant being calculator. It's a quadratic equation, so if we move everything over to one side, we will get 0 equals 10x squared. 360 plus 360, 720 minus it, minus 420x, minus 10,800. Whew. Can you see anything that you can factor out? You can factor out a 10. That'll make it a little bit easier. X squared minus 42x minus 10,080. And now the factoring gets a little bit tricky. These two together would make 720. And if I subtracted that on the other side, I moved it over to the other side, and then that 300 makes negative 420. Okay. $21 doesn't work. One of them is going to have to be positive, and one of them is going to have to be negative. Because you need to get a negative 10,080. So, how about 60 and 18? Does that work? I think it might. What's 60 times 18? Is it 1,080? Yes? No? Did someone check? It works? Yep. All right. So then you get two answers. X is either 60 or X is negative 18. We have to check our non-permissible values. Our non-permissible values from before, X can't equal 0 and X can't equal 30, negative 30. So neither of those are non-permissible values, but this is a word problem. What was X standing for? X was standing for the speed, right? The speed on the way there. So can you see that negative 18 doesn't really work? Because you'd be driving backwards. So the only answer then that makes sense is 60. Now, if we go back to our chart, let's see if our answer actually makes sense. If we put in 60, and I'll write it in blue, then what's our speed here? 90. And 360 divided by 60 would be how many hours? 6 hours. And 360 divided by 100, or 90, right? Because 60 plus 30 would be 90, would be 4. Does that add up to 10 hours? Yes, it does. Okay? Where this one doesn't work very well is the factoring has really, really large numbers. It's not always going to be really, really large numbers, but sometimes it's going to be large numbers.